Hello, sixth graders. We are in section 2.5, which covers similar figures. So what are similar figures? Now you already know that congruent figures have the same size and shape. Similar figures have the same shape, but not necessarily the same size. These are called similar figures. So here it is. Now, figures that have the same shape but not necessarily the same size are called similar figures. As you can see here, we have two triangles that are not the same size. Now, angle A and angle D are corresponding. Angle B and angle E are corresponding. Angle C and angle F are corresponding. Now, what does that mean? Corresponding angles. We're going to go right here. Huge piece of information that you need to know. Corresponding angles are congruent. It does not matter like a rectangle or a square. It doesn't matter how big a square is or how little a square is. The angles are still going to be congruent. Now, the sides are proportional. The sides are proportional. That means if I take the length of AB, notice that we are not naming segments, but the length of AB divided by the length of DE is equal to the length of BC divided by EF and the length of AC divided by DF. We can write them as proportions. The angles are congruent, and therefore we say that triangle ABC is similar to triangle DEF. Now make note of a couple things. Number one, what does it mean if things are similar? Well, you should know right here. The symbol, which is a tilde mark, means is similar to. In addition, when you write a similarity statement, the similarity statement, you have to make sure that the list of vertices are in the correct order. So notice we are color-coded here. A and D are corresponding congruent angles, therefore they're listed first. B and E and C and F. Now you could have done this. Triangle CBA is similar to triangle, let's see, CBA, then we can go backwards, BED. That is also acceptable, but they have to be corresponding and go in the correct list or correct order of vertices. So let's look at example number 1, identifying similar figures. I want you to identify them. Which of these figures are similar? What you have to do is this. Since we know these are rectangles, we know that all of the angles here, here, and here are all 90 degrees. So the corresponding angles are all congruent. However, we have to see if the corresponding side lengths are proportional. So let's test A and B. So rectangle A and rectangle B. The ratio, it doesn't matter which one you start with. I'm just going to start with A to B. So the widths have the ratio of 3 to 2. The lengths have a ratio of 6 to 6. Well, wait a minute. That's 3 halves. That's 1 to 1. These are not proportional. Now, if we try A and C, the widths have a ratio of 3 to 2. The lengths have a ratio of 6 to 4, which equals 3 to 2. Therefore, the widths and the lengths have the same ratio. Therefore, our answer, A, is similar to C. Rectangles A and C are similar. Now we know that the triangles are similar. If the triangles are similar, we know that the angles are congruent, but we now need to find one of the missing sides. We just write a proportion. 6 and 9 are corresponding, and that means 8 over x are corresponding. Easy. We cross multiply, do the cross products. 6x equals 72. By the division property, I can divide by 6. X equals 12. So the length of x would be 12 meters. And in our last example, we have a real-life application. An artist draws a replica of a painting that is on the Berlin Wall. The painting includes a red trapezoid. The shorter base of the similar trapezoid in the replica is 3 3/4 inches. What is the height h of the trapezoid in the replica? Well, we just set it up like we did our last problem. 12 corresponds to h. 15 corresponds to 3 3/4. I cross multiply, that gives me 15h equals 45. By division property of equality, I get 3. So the answer, the replica, the height, is 3 inches. The only vocabulary in this section is similar figures. Please make note that in similar figures, you must know that the corresponding angles are congruent and the corresponding sides are proportional.